The world of software development is no stranger to automation. Over the decades, we've seen a steady evolution of tools designed to make coding more efficient and less error-prone. From the early days of simple text editors to the sophisticated integrated development environments we use today, programmers have always sought tools to streamline their workflow and boost productivity. Compilers, debuggers, and version control systems have all played a crucial role in this journey. In recent years, a new breed of assistant has emerged, powered by the rapid advancements in artificial intelligence, the AI coding assistant. These tools leverage machine learning algorithms to understand and predict the needs of developers. Among these, GitHub Copilot stands out as a particularly ambitious project, aiming to transform the way we write code. By analyzing vast amounts of code from public repositories, it can offer context-aware suggestions that can significantly speed up the coding process. These AI-powered assistants are designed to act as virtual pair programmers, offering code suggestions, auto-completing repetitive tasks, and even generating entire code blocks based on natural language prompts. They can help reduce the cognitive load on developers, allowing them to focus on more complex and creative aspects of their projects. The promise is tantalizing. Faster development cycles, reduced errors, and a lower barrier to entry for aspiring programmers. By making coding more accessible, these tools have the potential to democratize software development, enabling more people to bring their ideas to life. But how well do these tools perform in the real world? Are they living up to the hype? Or are there still significant challenges to overcome? As we continue to integrate AI into our development workflows, these are the questions that will shape the future of software engineering. At the heart of GitHub Copilot lies GPT-4, the latest iteration of OpenAI's powerful generative pre-trained transformer model. GPT-4 is a deep learning model trained on a massive dataset of text and code, enabling it to understand the nuances of human language and the intricacies of programming languages. This allows Copilot to parse your code, understand your intent, and generate contextually relevant suggestions. The model's ability to learn from vast amounts of data is both its strength and its potential weakness. While GPT-4 excels at pattern recognition and code generation, it can sometimes produce incorrect or inefficient code, highlighting the need for careful scrutiny and testing. To assess Copilot's capabilities, I tasked it with a real-world coding challenge, building a simple WordPress plugin. The plugin needed to add a custom meta box to the post editor, allowing users to input a short text string and display it on the front end of the website. Copilot impressed me with its ability to generate the basic plugin structure, including the necessary PHP functions and hooks. It even correctly identified the required WordPress API calls for adding meta boxes and saving custom fields. This demonstrated Copilot's understanding of the WordPress ecosystem and its ability to leverage its knowledge to generate functional code. However, Copilot's limitations became apparent when I moved on to more complex tasks. Initially, I was impressed by its ability to handle straightforward coding problems. It seemed like a dream come true for any developer looking to speed up their workflow. I wanted to create a function that would format a user-inputted number as a currency string. This is a common requirement in many applications, especially those dealing with financial data. This seemingly simple task proved surprisingly challenging for Copilot. Despite its advanced algorithms, it struggled to handle the nuances of currency formatting. While it could generate code that appeared correct at first glance, closer inspection revealed edge case errors that would cause the function to fail under certain conditions. These errors were not immediately obvious but could lead to significant issues in a live application. For instance, Copilot's code didn't properly handle empty strings, which are a common edge case in user input scenarios. It also struggled with leading or trailing decimal points, or leading zeros. These are subtle issues that can cause major problems if not addressed. This highlighted a key weakness of AI coding assistants: their reliance on pattern recognition. They can mimic code patterns but often miss the deeper logic required for robust functionality. While Copilot could generate code that resembled what it had seen in its training data, it lacked the ability to fully understand the context and intricacies of the task at hand. It struggled to reason about the underlying logic and anticipate potential edge cases. This experience was a valuable lesson in the current limitations of AI in software development. Despite these limitations, Copilot demonstrated moments of genuine brilliance, showcasing its potential to be an invaluable tool for developers. In one instance, I encountered a particularly perplexing bug related to WordPress API calls. The issue was causing unexpected behavior in the application, and I was at my wit's end trying to figure it out. After hours of fruitless debugging, I turned to Copilot for assistance. I was skeptical at first, but I decided to give it a try, hoping it could provide some insight. To my astonishment, Copilot correctly identified the issue, suggesting a subtle change in the code that immediately resolved the bug. It was a small but crucial adjustment that I had completely overlooked. In another instance, Copilot excelled at generating a complex script that interacted with AppleScript, Chrome's Object Model, and Keyboard Maestro, a Mac automation utility. This script was essential for automating a series of repetitive tasks that would have otherwise taken hours to complete manually. The script involved intricate interactions between these different environments, and Copilot flawlessly tailored the code for each platform. It seamlessly integrated the various components, ensuring smooth operation across the board. This demonstrated Copilot's potential for simplifying cross-platform development, a task that often requires deep knowledge of multiple programming languages and APIs. By leveraging Copilot, developers can save significant time and effort, allowing them to focus on more creative and complex aspects of their projects. Based on my experience, GitHub Copilot in 2025 is best described as a powerful but imperfect tool. It excels at automating repetitive tasks, generating boilerplate code, and offering suggestions based on your coding style. It can be a valuable asset for experienced developers looking to boost their productivity and explore new programming paradigms. However, it's crucial to remember that Copilot is still in its beta phase and should not be treated as a silver bullet solution. Its code suggestions should always be carefully reviewed and tested, and it's essential to have a solid understanding of the underlying programming concepts to identify and correct any errors. Looking ahead, the future of AI coding assistants like GitHub Copilot seems bright. As these models continue to learn from vast amounts of code and receive further refinement, we can expect significant improvements in their accuracy, reliability, and capabilities. The ultimate goal is not to replace human programmers, but to augment their abilities, allowing them to focus on higher-level tasks such as problem-solving, design, and innovation. The future of coding lies in collaboration between humans and machines, where AI assistants become trusted partners, helping us to write better code, build more sophisticated software, and unlock new realms of creative possibility.